Okay, Aiden, I got this copy sent to me. It looked like it was only one side of a worksheet though. It started with problem number 10, so I have a feeling there's got to be another side to it. And it kind of looks like this might be a review, so you might, I don't know if you have a test coming up on Friday, but I'm going to go ahead and show you how to work these problems out, and then we'll figure out what's going on if there was a first page. I want to evaluate these first expressions over here. To do that, I'm going to first start off noticing that this example, it has the radicand is negative 125 and that it's a cube root. So I think about my perfect cubes. Now remember, you can take the cube root of a negative, you just can't take an even root, like a square root or a fourth root of a negative, and it'd be a real number. It'd be an imaginary number. But in this case, I'm going to get a real number, and I know you know your perfect squares, but you also should know your perfect cubes a little bit too, like 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27, and 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. This is negative 125. So it's negative 5 times negative 5 times negative 5. And I'm taking the cube root, so this is negative 5. Because if you take this times itself again, you'll get right back to the radicand. Now this expression, be careful with that negative. The negative is not being raised to the 2/3 power. The only thing that's being raised to the 2/3 power is the 27. Otherwise they'd put parentheses around it if they wanted the negative as part of it. Kind of like this has parentheses around it. So just the 27 is to the 2/3 power. Now remember, this is the index of the root and this is the power. So this is going to be the opposite of whatever this expression is. Well, this expression here is the cube root of 27, cube root of 27 squared. The cube root of 27 is 3, because 3 times 3 times 3 is 27. So 3 squared is 9. My answer is negative 9. Negative 9 because that's a negative right there. Now in this case I have a fraction raised to a negative power. And you may or may not remember, I told you that when you have a fraction to a negative exponent, that you can take the reciprocal of that fraction, which would be 216 over 1, to the positive exponent. Positive. And then I write down negative. That's good. Positive exponent. Well, 216 over 1 is 216, so this is the cube root of 216. Now, you have to kind of consider what possible factors of 216 there are that are perfect cubes. For example, 8 is a perfect cube, and 8 divides into that 27 times. 27 is a perfect cube, and it divides into it 8 times. But here's the kicker. This 216 is 6 times 6 times 6. 6 times 6, 36 times 6 is 216. So this is going to equal just 6. Okay, just 6. Now remember, a minute ago, and not that I would expect you to write it this way, I said that this was the cube root of 8 times 27, and both of these are perfect cubes, so this is the cube root of 8 times the cube root of 27. That's 2 times 3. There's my answer. It's much simpler if you find that largest value that's a perfect cube in this case that divides into it. In fact, it was the number itself. Now here they put parentheses around this expression. I didn't see an exponent outside unless my copy just got a little too faint. But I am assuming that all they want you to do here is to multiply these, and they already have the same base. They're both base 3. So when you multiply and they have the same base, you add the exponents. So now you have to add 1/2 plus 1/3. My common denominator is 6. This is top and bottom by 3, top and bottom by 2. This is going to be 5/6. So this is equal to 3 to the 5/6 power. Now, if he wants it written as a radical, that's the index, that's the power. So you could write this as the 6th root of 3 to the 5th power, like this if they wanted it. Or the 6th root of 3 raised to the 5th power, putting it on the inside. I'm going to guess they probably want that. Now these last two are getting a little messier because they threw some variables in. But we've looked at these before, and we can use the little shortcut that I showed you where you treat the index as if it was a divisor for these variables and their exponents. Now the nice thing about a 5th root, 32, is a perfect fifth. It's 2 times 2 times 2 times 2 times 2. So if I take the 5th root of 32, that's 2. If I take the 5th root of x to the 6th, Well, here's the shortcut. You divide 5 into 6 into the exponent. It goes in one time with 1 left over. Notice the 1 time comes out, the whatever's left over goes in. And then I divide 5 into 5, it goes in 1 time with none left over, and that's what that simplifies down to. That could have been a lot worse. This guy here, I kind of like the fact that my index for my root here is the denominator of this rational exponent. It's the 3. This is a cube root. Because I'm looking at these numbers, they're perfect cubes. This is 3 times 3 times 3. This is 2 times 2 times 2. And these are divisible by 3, so these are powers. These are also perfect cubes. So if you chose to do this, you could write in this manner. Because all that's going for you, you could think of this as the cube root of 27x to the 6 over 8y to the 12th, and then you're going to square it. Well, the cube root of a fraction is the cube root of the numerator over the cube root of the denominator, and all that's going to be squared. This is going to be 3. 3 goes into 6 twice with none left over. This is going to be 2. 3 goes into 12 4 times with none left over, and then all that gets squared. So I square the numerator, I square the denominator. Because you have the square of a fraction, it's the square of the numerator over the square of the denominator. 3 squared is 9, x squared squared, you multiply power to the power, you multiply the exponents. 2 squared is 4, y to the 4th squared, power to the power, you multiply the exponents, y to the 8th. And it took a few steps, but there's our simplified answer. These last 4 problems remind me of some of the problems from your previous assignment here. I'm going to go ahead and work these out kind of like I did on the other ones. You have a radical in this equation. It's already on one side. Now normally I'd like it on the left because I'm a variable on the left side kind of a guy. But I can leave it there, or I can switch the sides around. But I'm going to get rid of the radical. I'm solving for x by squaring, because that's going to do the square root. So I'm going to go ahead and flip-flop the sides. I'm going to have 7x minus 3. That's going to get squared. And the 5 is going to get squared. You square the square root, you get 7x minus 3. You square 5, you get 25. Now it's duck soup. I'm going to add 3 to both sides. I get 7x is equal to 28. I'm going to divide by 7. I get x is 4. If you want to make sure it's not extraneous, plug 4 back in. 7 times 4 is 28 minus 3 is 25. The square root of 25 is 5. This is a good answer. This guy has radicals, but the radicals are on the same side. What I'm going to do is I'm going to add this to both sides to isolate or to separate the radicals and get one of the sides where it's just a single radical. In fact, both sides will be just single radicals. So I'm going to add the square root of 3x to both sides, and I get the square root of x plus 6 is equal to the square root of 3x, because these are going to cancel out. I'm going to square both sides. Now, you're squaring both sides and the variables on both sides. You must check for extraneous solutions to make sure your answers are legit. So I square this side, and I square this side. This is going to be x plus 6. This is going to be 3x. Solve for x. It's easy now. The radicals are gone. You solve for x just like you did back in your Algebra 1 days. You get 6 equals 2x, divide by 2, x is 3. Now I'm thinking that's probably a good answer, but I'm going to make sure. I'm going to go back to the original problem, which I've already kind of marked up a little bit here. Hopefully you can still see this. If I plug 3 back into here, I get the square root of 3 plus 6, the square root of 9, which is 3, minus, plug 3 in here, I get the square root of 9, which is 3. I get 3 minus 3, that's 0. This is a good answer. All right, one more with a radical there, and it's already on one side, although I would typically like it on the left side. It really doesn't matter because I got the variable on both sides anyway. I'm going to, since this radical is already isolated, there's nothing times it, there's nothing being added or subtracted on the end. It's one big radical here. I'm going to square both sides because it's a square root. Now be careful. On this side, a lot of students excuse me, will square the x and square the 5 thinking that you square each term. You square the entire side. It's a binomial squared. You're going to have to do FOIL. On this side, I get the square root of 3x plus 13, and that gets squared. So this is going to be x squared plus 10x plus 25 when you do FOIL. The O and the I, don't forget. This is just going to eliminate the radical here, and I get this guy. Now, that's a quadratic equation. It's not in standard form, means it's not set equal to 0. That's my key here. To solve this, I got to get it set equal to 0. So I'm going to subtract 3x from both sides, and I'm going to subtract 13 from both sides. That gives me x squared, look right here, plus 7x plus 12 is equal to 0. Well, I can solve this by factoring. You don't need the quadratic formula. This is x plus 3 times x plus 4 is equal to 0. So now I come over to here. I set the x plus 3 equal to 0, or the x plus 4 has got to equal 0. Remember, this times this gives me 0, means one of these two guys is 0, or both of them are. So I set them both equal to 0, and I solve. I get x equals negative 3, and I solve, and I get x equals negative 4. It looks like I have two good answers. Well, maybe I do, maybe I don't. Let me check. If I plug negative 3 in, negative 3, back to the original, negative 3 plus 5 is 2. If I plug in negative 3 in here, I get negative 9 plus 13 is 4. The square root of 4 is 2. It matches. If I plug negative 4 in here, negative 4 plus 5 is 1. Good. Positive. Over here, plug negative 4 in. 3 times negative 4 is negative 12 plus 13 is 1. The square root of 1 is 1. 1 equals 1. These are both good answers. A lot of times one of them's extraneous and the other one's good, but in this case both of them are good. Now we jump down to these last two problems here that involve rational exponents. They're radicals. This is a cube root. This is a cube root that's being squared. So what I'm going to do is I'm going to undo the rational exponent here as about my last step by using that trick I showed you before where you raise both sides to the reciprocal power. But first things first, isolate this expression. Like, see how this guy's already all by himself? You got to get this guy all by himself. So undo, get rid of the 2 times to get rid of the 4 that's being added. I'll subtract 4. I get 2 times the quantity 1 minus 3x to the 1/3 is equal to 2. Divide both sides by 2. I get the quantity 1 minus 3x to the 1/3 is equal to 1. Now I'm going to raise both sides to the reciprocal of 1/3, which is 3 over 1, or 3. So I get 1 minus 3x is equal, well, 1 cubed is 1. Subtract 1 from both sides, I get negative 3x equals 0. Divide by negative 3, I get 0. Now a lot of students panic when they see that 0. 0 could be an answer. I just got to go back and check. So if I put a 0 here, 3 times 0 is 0. 1 minus 0 is 1. 1 to the 1/3 is 1. 1 to any power. 2 times 1 is 2. Plus 4 is 6. It works out. Legitimate answer. I haven't had a dud in the bunch. All right. This last one is here because of the idea that when you raise both sides to the reciprocal power, the reciprocal of 2/3 is 3/2. That means you're taking a square root because the denominators are 2, and that's going to pick up the plus or minus. I am going to raise this side to the 3/2 power. I'm going to raise the right side to the 3/2 power. Power to power, those are going to multiply and just give you 1, so I have 2x plus 1. 9 to the 3/2. Because I am taking it to the 3/2 power, technically this would be absolute value, but I'm going to pick up the plus or minus. 9 to the 3/2 is the square root of 9 cubed. So that's 3 cubed, or 27. Careful with me. I'm going to subtract 1 from both sides. Now this is where it gets a little tricky. I'm not going to try to subtract 1, write this as plus or minus 26. I'm going to write this as negative 1 plus or minus 27. Then I'm going to divide by 2, and I have two answers here. Negative 1 plus 27 divided by 2, negative 1 minus 27 divided by 2. Negative 1 plus 27 is 26. 26 divided by 2 is 13. Negative 1 minus 27 is negative 28. Divided by 2 is negative 14. And you can plug them both in, but I'm going to tell you right now, I know that both of those guys are going to be fine. Those are both good answers. Okay, I suspect you might have a little bit more, but this will be good review for you all the same. Make sure that you try the problems before you watch the problems worked out by me. It'll make more sense to you that way, and if you've made a mistake, you'll see the reason why. So when you do these, show all of your work, and then try the problems and match them up that way. And I'll talk with you later on about this.